Okay guys, so we're going to add a section into your chapter 9, and this is called Simplifying Square Roots. We're going to call this chapter 9.1b. This is not in your book, but it is something that we want you to know, how to simplify square roots. So yesterday we talked about how to type it in your calculator and get an exact number. Now today we're going to show you how to simplify square roots, and you'll use this in algebra and in geometry and beyond. So I want you to have this skill. Go ahead and get this copied into your notes, these key concepts, and then replay me when you're ready for the explanation. Okay, so we've got the simplest form of a radical expression. This means that no factor under the expression under the radical sign, no factor of the expression under the radical sign has any perfect square factor other than 1. Then there are no fractions under the radical sign and no radical sign in the denominator of any fraction. Okay, so it's kind of faux pas if we have a fraction in the denominator, oh, not a fraction, radical in the denominator, no fractions under the radical, and we can't have any perfect square other than 1. Then we've got the product property of square roots and the quotient property of square roots. The product property says that I can have the square root of a product, a times b, let's say, and split this up into the square root of a times the square root of b. Similarly, I can have the square root of a times the square root of b is the same thing as saying the square root of a times b. Okay? In numbers, it's got the square root of 9 times 7 is the same thing as saying square root of 9 times the square root of 7. Or square root of 9 times the square root of 7 is the same thing as saying square root of 63. Quotient property of square roots. When I have one big square root with a fraction underneath, square root of a, or square root of a over b, I can split this up into two square roots. So I've got the square root of a over the square root of b. So I'm keeping that square root, and I'm just basically splitting it up into 2. So then I've got square root of 11 over 4. It's the same thing as saying square root of 11 over the square root of 4. Okay, let's do some examples. Now, when I have just a number like this, the first thing that I want to do is I want to find your prime factorization. And if you can recall, this is just factor trees. Okay, so we're going to do our factor tree. 180 can go into 18 and 10, and we have this as 2 and 5. I like to circle my primes so I know that they're done. 2 times 9 and 3 times 3. Okay, so now I've got the prime factorization, which is the factor tree. This is all something that you should be aware of. Our second step is we want to list all prime numbers from least to greatest. And this is all going to be under one big square root. So I've got 2 2s, I've got 2 3s, and I've got 1 5. Okay. Our next step is we are going to find your pairs. Circle. Okay, so I'm going to come in here. All right, I've got pairs which come in 2s. Pairs come in 2s. There's a pair of 2s here and a pair of 3s here. And step 4 says to cross them out. Bring 1 out. Okay, so I'm going to cross it out, bring 1 out, cross it out, bring 1 out. So this is going to be on the outside 2 times 3 times the square root of whatever's left on the inside. We only have 1 5. Okay, and then we multiply outside and inside, if you have any on the outside and inside. So this is 2 times 3, which is 6, square root 5. So your simplified version of square root of 180 is 6 times the square root of 5. Okay, I want you to try this one using the exact same steps as we did before. Pause me and replay me when you're ready for the answer. Okay, so we factor this into 9 times 7. 7 is prime. 3 times 3. And we list underneath the prime, or square root, 3 times 3 times 7. We've got one pair of 3's. Cross it out, brought one out. And our square root, simplified square root, is 3 times the square root of 7. Okay, so we've got, now we've got the same thing, except for we have something squared. Okay, so we want to do our factor tree, find our primes, and the exact same steps as before, 2 times 2 times 2 times 3. Now, when we have variables, you want to list all your variables so your exponent is no greater than 1. So we're just going to say times s times s. Okay, so there's s squared, there's 2 s's, you just write them all out. If it said s to the 5th, you would have 5 s's down here. Okay, and we find our pairs. Cross one out, bring one out. So we have 2 times s on the outside, and we're left with 2 times 3 on the inside. And we multiply them together, and 2 times s is 2s times the square root of 6. So 24s squared is 2s times the square root of 6. Okay, so we had a brief intermission for dismissal, but we're back now. So hopefully you guys got this example. And I want you to try this example. Pause me and try it as best you can, and replay me when you're ready for the answer. Okay, so first of all, we need to factor this. 54 into 9 and 6, 2 and 3. And we make one big square root with our factors listed, 2 times 3 times 3 times 3. So there's 1, 2, 3 3's, and we want to list out all of our variables, so it's t times t. Circle your pairs. We've got one pair of 3's and one pair of t's. So cross one out, bring one out, and we're left with 2 times 3 on the inside. We multiply the outside together, we get 3t, and we multiply the inside together, we get 6. So your answer is 3t times the square root of 6. Okay, so now we've got this example where we have a fraction under the square root, or a division sign. Now, whenever you see this, you want to split it up into 2 square roots. Okay, so we're having one big square root, and we're going to split it up into 2 little ones, the square root of 13 and the square root of 36. Now, so we've got one big one, we split it up into 2 little ones. Now, before I said that it wasn't simplified if we do have a square root in the denominator. So first of all, you want to get rid of the square root in the denominator. And how we do that is it's called rationalizing the denominator. And it's a big word. Don't be freaked out. All you need to do is you need to multiply the top and bottom by the bottom. Okay, so you see the bottom here as a square root of 36, and I'm going to multiply the top and the bottom by the square root of 36. And then from here, I'm just going to multiply straight across just as if this were a normal fraction. Okay, so just 13 times 36 is, in your calculator, you should get 468. And then you multiply the bottom just as if this was a normal fraction, 36 times 36, which is a square root of 1,296. Okay? Now, you want to do your factor trees for 1,296, but we just found out that 36 times 36 is 1,296. So the square root of 1,296 is simply 36. You can type that in your calculator if you don't believe me, or if you want to do it yourself, you can do that. But square root of 1,296 is 36. But square root of 468 is not as nice. You get a decimal if you put that in the calculator. So we want to simplify this. And we can simplify 468 into 13 and 36. 13 is prime. 6 times 6, 2 times 3, and 2 times 3. So we list this all under a square root, and we have 2 times 2 times 3 times 3 times 13. We got one pair here. 2 times 3 times square root of 13, which is 6 square root 13. Okay, and then from here you can simplify the outside. Okay, you don't want to touch the square root. We just look at the outside numbers. And can 6 over 36 be simplified at all? And that is correct. It can be 1 over 36. So we have a square root of 13 over 6. And that's just because 6 over 36 equals 1 over 6. Okay. And here's your turn example. I want you to try this one as best as you can. And replay me when you're ready for the answer. Okay, so first of all, you were supposed to split it up into one big one, into two little ones. Square root of 15 over the square root of 16. We got to get rid of this denominator and times the square root of 16 times the square root of 16. We're taking the bottom one, multiplying it by the top and bottom. And 15 times 16 is the square root of 240. 16 times 16 is square root of 256. When we square 256, we get 16 back. And when we square root 240, that's going to be kind of a decimal here, so we're going to simplify this into 24 and 10, 2 and 5, 4 and 6, 2 and 2, 2 and 3. Okay, so we list under here, we have 1, 2, 3, 4 2s, 1, 3, and 1, 5. So we find our pairs, cross one out, bring them out. We have 2 times 2 times 3 times 5, which is 4 times the square root of 15. So we come up here, square root of 15. And can we simplify the outside numbers? Don't touch the square root. You can't take anything out of that. But if you can simplify 4 over 16, go ahead and do that, which is really just 1/4. So we have square root of 15 over 4. And that is your final answer, square root of 15 over 4. Okay, here's some practice problems I'd like you to try. Do the best you can, and we will go over them first thing tomorrow.